It's me again, Lecturer Joe. In this video we're going to look at the process known as rectification, and that's a process of converting AC electricity to DC. If you haven't watched the video about what the difference is between AC and DC, I recommend you take a look at that before watching this one. So we're going to be showing you how this is achieved using diodes, so there's a separate video on diodes which you need to watch before taking a look at this. So what we have here is a lamp connected through a switch to an AC supply. This is pretty much a diagram of what you have at home for your light switch. And when we close this switch, we get a flow of electricity and the lamp lights up. Now, the question is, what way does this electricity flow? Is it flowing clockwise or anti-clockwise? And as you've hopefully picked up by now, because this is an AC supply, it's actually doing both, though not at the same time, obviously. It goes forward, back, forward, back, forward, back, 50 times per second. So if this pen represented the current flowing in this wire, it would actually be doing this, back, forward, back, forward, back, forward, but much faster than I can move a pen, 50 times per second. And this is known as the frequency of the supply, and it's measured in a unit called hertz, which is usually shortened just to HZ. So this is a 50 hertz supply. So when you flick a switch at home and the light comes on in your living room, the cables running to that light are carrying electricity which is going back and forward 50 times per second. Now, for reasons we're not going to go into here, all of the electrical supplies you have at home are AC, alternating current, where the current flows back and forward. But almost all electronics wants to run off DC, direct current, where the current always flows in one direction. So we need to look at how it's possible to convert AC to DC. Back to our circuit of the AC supply, the switch and the lamp, and we've got a current flowing back, forward, back, forward, back, forward 50 times a second. And we can stop it from flowing backwards, meaning it will only flow in one direction, by inserting a diode in here. So by putting a diode there, the current can flow forward, but it can't flow backwards, because in trying to do so it would be trying to go backwards through the diode. Now that will work, but the problem there is that we only get half of our power. We only get power when the current flows forward, but we get no power when the current flows back. What we really need is a system that will give us full power. That is, the polarity here, positive, negative, switches about, back, forward, we get a constant flow of current in the one direction through the lamp. So we'll take a look at how that's achieved. So let's see what we have here. On this side we've got a 5-volt supply, AC, and over here we've got your mobile phone. Your mobile phone wants to charge off a 5-volt supply, but it wants to charge off a DC supply. So in the middle here we need some way of converting AC to DC. So what we do is we connect 4 diodes like this, 2 pairs, 2 diodes on a line here, 2 diodes on a line here, and then we wire them up in a clever way. You know that the current wants to flow through these diodes up the way, so this is going to be the positive here, and then it wants to return, having gone through the phone, along the bottom here. So top and bottom supply the positive and negative to the phone. That's where the DC is going to come out. The AC then goes into the only other place we have available, which is here and here. Now let's look at how this arrangement works. Over on the left we have an AC supply where the current wants to keep flowing back, forward, back, forward, back, forward, 50 times a second. Over on the right here we hope it to be a DC supply where the current always flows from positive through the phone to negative. So on this side, the current is always going to be flowing downwards. Here, it's always going to be flowing back and forward. But this arrangement of diodes makes sure that one is converted to the other. So let's just label those diodes first. So this is diode 1, diode 2, diode 3, and diode 4. You'll remember over at the left here where we have an AC supply, the reason that the current flows back and forward continually is because the polarity here, the voltage, keeps switching over. Positive, negative, positive, negative, positive, negative. So sometimes it's positive at the top, negative at the bottom, and then a fraction of a second later it's the other way about. Positive at the bottom, negative at the top, and then switches over again. Back, forward, back, forward, back, forward. Just as if this is a battery where we keep swapping the wires on the end of the battery. And that's the reason why the current keeps flowing back and forward. So let's look at those two scenarios. Let's consider the time when it's positive at the top and negative at the bottom. And let's see what happens to the current flow. So if it's positive here and negative here, the current's going to flow in here, and it can't flow downwards through this diode because it'll be going the wrong way. So it has to flow up through this diode, along. Can't flow down through this one because that's going to be the wrong way. So it's going to flow along there, through the phone, from top to bottom, just like we want. Out of the phone, back, and remember it's trying to get back to the negative here, so it's going to flow up D4 and back out. So when it's positive here and negative here, it's flowing through D1, through the phone, and back through D4 and out. That means only two of the diodes are conducting at that time, D1 and D4. Now let's think about the time a split second later whenever the polarity switches over here. So now the current flow wants to come in here from positive to negative, remember, so it's going to flow in here. It can't flow through D4 because that's the wrong way, so it's going to flow up through D2. Can't go through D1 because that's the wrong way. Going to flow out here, down through the phone, top to bottom, and this time it's coming back. We're trying to get back to the negative here, so it's going to flow along and out the top. So this time, with positive at the bottom and negative at the top, it flows through D2 and back through D3. So first time round it was D1 plus D4, second time D2 plus D3. And of course when it swaps back over again such that it's negative at the bottom and positive at the top, and we're back to this situation, D1 and D4 again. So this process just keeps going on forever. As the polarity here keeps swapping positive, negative, back, forward, back, forward, back, forward, these diodes switch on in pairs. Those two, those two, those two, those two. And that way, although the current here is going back and forward, the diodes are directing it so that it always flows along the top, from top to bottom, positive to negative, through your phone and back out again. It's worth remembering, as we covered in the video on diodes themselves, that we lose about 0.7 volts across each diode. So in this particular circuit, if we had a 5 volt supply, we wouldn't have 5 volts DC here. We'd have something in the order of 3.5, because we'd have lost around about 0.7 in each of the two diodes. So when D1 and D4 are on, we'd lose 0.7 there, 0.7 there, giving us about 3.6 left at the phone. So in reality we would need this voltage to be a bit higher than that. Maybe about 6.5 volts AC to run this. So if we sketch a graph of what the voltage looks like going into the rectifier and coming out, the voltage going into the rectifier, because it's an AC supply, it's going positive, negative, positive, negative. Whereas coming out of the rectifier, the voltage is always positive. So we don't get this bottom half. In fact, the bottom half gets flipped around here as the other pair of diodes redirects it. Now this is still a pretty bumpy voltage, and it's not the sort of thing we'd want to put into our phone. So the last thing I want to show you is how this gets smoothed out to become completely smooth DC, similar to that which you would receive from a battery. We go back to our rectifier again, our 4 diodes pointing upwards, AC coming in to the left in the middle, DC, positive, negative, coming out at the right hand side, and that's going to give us that familiar bumpy DC that we looked at a moment ago. And in order to get rid of that and make it completely smooth, such as you would get from a battery supply, we need to put a capacitor in here, and that capacitor acts to smooth out these bumps and give us a nice smooth DC out. So to recap, a diode is essentially just a one-way switch or a one-way valve. If you think of it in terms of a valve in a pipe, it only lets the water flow in one direction but not backwards. They're often used to convert AC to DC, and that's a process called rectification. To do that, we generally use 4 diodes in the arrangement we saw there, with 4 pointing up, positive, negative out, AC into the middle. When we build one of these rectifiers, when we feed AC in, we find that the DC we get out is bumpy, and to cure that we got to fit a capacitor. Fit a capacitor on the output, and that gives us a smooth DC similar to that which you would achieve from a battery supply. And finally, not forgetting, the symbol for the diode is the arrow with a stripe at one end. Current can flow through it in one direction, the direction I've ticked there, but not backwards. And it's worth noting the names of these 2 ends. This end, where the positive is called the anode, and this end called the cathode. So current can only flow in the direction from anode to cathode. Current can't flow backwards. So there you have it. That's pretty much your introduction to rectifiers.